Welcome back, students. So we are here after some more days. For the few days I was busy with my other works, and I had some exams happening here around somewhere. So I was busy. So but I'm back here today. So I'm planning to do some questions that is some numerical questions of physics. So this some numerical questions from a specific shift of 2024. So this is from the January 28th shift of Jan 28th shift of JEE Main 2024. This is the first question. So we'll be doing numerical questions. Okay. When a hydrogen atom is going from n equal to 2 to n equal to 1, emits a photon. Okay. So first of all, this is n equal to 2, n equal to 1. So there is a Balmer line here. No, not Balmer, Lyman line. An electron is going from here to here. First of all, what is the energy? You know that is energy. What is the energy? It is 13.6 into z square by n square. So it is a hydrogen atom. So z is 1. So it is just 13.6 by what is n square? From where is it coming? From where is it coming? Yes, it is coming from 2. So 4. Calculate 13.6 divided by 4. That will be 3 times 12, 1. Okay, 6, 4. It will be 3.4. Electron volt. 3.4 electron volt, right? Yes. 1 second, electron volt itself. So next one, this we got. Now what do we have? This thing we got. Now they have asked us to find the recoil speed. You know that mv is equal to h by p. H by lambda. Right. So they are asking the recoil speed. So v equal to h by lambda into m. Sorry. Not this is not the formula. Sorry. You know that difference in energy is equal to h by mc. Yeah, h by p mc. Yeah, this is equal to m. Is equal to m. What is it? It's equal to mv. Right? Everything if you tell right, it's wrong. Okay, sorry. Delta E is equal to h by mc because C, it is happening in air itself. So h by mc. You know that this is a normal equation. Right? Yes. Sorry. Something happened. Sorry. So listen. I don't know. I am disturbed now. Why I don't know, but I'll explain it once again. Sorry. So we are having recoil speed. You know that mv, momentum, is equal to change in energy by c. Okay. Yes. So from here v is equal to delta E by mc. Delta E we know that is 3.4 electron volt. Which unit should be calculated? Meter per second. So 13.4 into 1 second. Energy difference we should calculate. Okay, that is 3.4. So here what's happening in first it is 13.6. Here it is 3. This is just energy of the second one. Sorry. This is 3.4. So what is the energy difference? It is 13.6 minus 3.4. This is the delta E. That is equal to 6 minus 2. That is 10.2 electron volt. So here we should substitute not 3.4 electron volt but 10.4 into 10 raised to minus 19 into 1.6 because it's in electron volt. We should convert it into joule because we need it in meter per second. Now by mass of hydrogen is already given, that is 1.6 into 10 raised to minus 27 kilogram. That is 1.6 into 10 raised to minus 27 kilogram into C, that is 3 into 10 raised to 8. Now calculate it. 1.6 goes off. Okay, 27 and 8. So that will be 10.4 into 10 raised to minus 19 into 10 raised to what? 27 minus 10 raised to 19. So this will be cutting off. This will be cutting off. These things will be cutting off. So now we have just 10.4 divided by 3. What did they ask? Yes, x by 5 in x by 5 terms. Okay. So what's happening here? Yeah, 10.2 by 3. Now we need to make it into 5 terms, in terms of 5, right? In terms of 5. So let us write it like this. It's equal to x by 5. For x equal to 10.4 by 3 into 5. Okay. Is it 10.4? It's 10.2. That's a problem. It was 10.2. I also think because it should be divisible by 3, otherwise this is never happenable. So 2. Okay. This thing can be written as this. Like how can we write it? Can be written as this is 9 times. No, not 9 times. 3 times 1, 12, 4. 3.4 into 5. That is 3.4 into 5. 20, 6, 7, 8. It's coming like this. One second. There is some issue. The answer is not this thing. I think we made a mistake. That is, we did 10.2. What is 27 minus 8? It is 19 itself. Right. So 10.2 by 3. That's what we need to calculate. Yes. Okay. This will be 1 time. This will be how many times? 3.4. Okay, now multiply down and bottom and down into 5. That will get into 5 by 5. 3.4 into 5. 3.4 itself, right? 3, 1, 12, 4. 4 itself. 20. 5 3s are how much? 15, 16, 17. Yeah, I told it's 8. What a foolishness. 17 by 5. So it is x by 5. Therefore, x equal to 17. So this question I took a long time because I went wrong by substitute. This mistakes everyone can get. This mistake. Okay, now this question is over. Next question. Yes, so next question is here. Okay, this is a question from which one? Relative velocity. No, not relative velocity or what? One second. Sorry, my pen fell down. Yes. So this question is from what? Projectile motion, something. Okay. So a ball rolls off the top of a stairway with a horizontal velocity u. So they are telling that there are steps like this. Let us draw some steps. So a ball is here. It is coming down with the u velocity. What should be the minimum velocity u with which the ball just hits the step 5? So ball just hits. This just word is very important. So they are telling that ball just hits the step 5. So you understand one thing. Just hit means you take it that it is hitting at the end or extreme portion of the 4th step. That is, let us calculate. That is, this is 1, 2. I will take this ball. 1 second. So let it be here in the first step. It's coming with you. Okay. 3 and 4. You just take, this is the 5th step. They are telling it just hit the 5th step. So you can take it as just hitting 5th step means it hit the extreme portion, that this portion of the 4th step. For every question you should take like that, otherwise you will never get answer. Some children will take it like this. They will take it like this. This is wrong because they are telling it is just hitting. Just means just miss. We say just miss. So you take it till the end of this 0.4, and extreme portion of this 0.4. Okay. That's what we have to do. Now they have told that this step is having 0.1 meter height and 0.1 meter width. Okay. So totally, how many horizontal distance, x component distance is traveled? How much? 1, 2, 3 and 4. So 4 times it travels. So total x component is 0.4. So in projectile, as this is the projectile motion, we can call this x as what? The range of the projectile motion. Okay, yes. Now what is the horizontal height it traveled? Total height. This is 0.1, 0.1, 0.1. Right? No, one second. Really. Sorry. I just missed something. Look, it is standing at the end of this is zeroth step. From here it is falling. So we should take this height also. We forgot something. Yes. So it's falling like this. So total height is 1, 2, 3, 4. Right? 1, 2, 3, 4. Okay. So we are having how much? Height as 0.4 meter itself. You know that what is the range? The x component. Range is equal to u into t, because u is the what? Horizontal velocity component, u into t. So from here you get that t is equal to 0.4 by u. This is very important, t. Now you know that you apply what? Equation of motion for here. You know that you can calculate this is h. So I am taking the equation h equal to ut plus half at square. Initially you take the velocity to be 0. Okay. So we have h equal to half a t square. Here a is what? Gravity. So it is half g t square. So from here h we know that is 0.4 meter, substitute. And g we know 10. And t also we know what? 0.4 by u whole square. Now we can calculate u from here. 1 cut, 1, 5 into 0.4 we get 2. So that we are getting is what we are getting. Once again, let me take the question. We need the answer in form of root x. So u is equal to root 2. So therefore x equal to what? 2. Okay, this is the answer for this question. Now next question. Yes, 1 second. Yes, we have the next question here. Yeah, I took the question because if I cut in square, there are many notes and all that have written and kept in that book, so I could not take it. Notes means not of this question, of some other previous capacitor questions, because capacitance chapter is a bit difficult for me, so I used to do many questions from that. So 53, square loop. Okay, this is a question from what? EMI-AC. EMI-AC. I'll make this question short. Okay, a square loop of 10 centimeter. So I am drawing, first of all I am drawing the north, west, east coordinates. That is north, south, east, west. So first of all, a square loop of side 10 centimeter and resistance 0.7 ohm is placed vertically in east-west plane. And nothing. It is placed in the east-west plane. That is, this is the east-west plane. Okay, it is placed in the east-west plane. Okay, yes. Now what is happening? Yeah, it is having 10 centimeter side. Resistance, let it be there. But for this question, really we don't need that resistance. A uniform magnetic field of 0.2 Tesla is set up across the plane in northeast direction. So one second, I'll rub this thing and write it the other side. Okay. This 10 centimeter. No, in northeast direction there is a magnetic field of 0.2 Tesla. You know that this northeast direction and east direction make what angle? 45 degree. Then only it will be here also 45 degree, totally 90. You know that. You are learning geography and all. So there's a 45 degree angle made. So what? First of all, you know that they have asked us the magnetic field is decreased to what? It decreased to 0 in 1 second. So there's a time that is given as 1 second. They're asking us the induced EMF. How to find induced EMF? You know something that EMF is equal to minus d phi by dt. Right? That is you know that phi. Okay, d phi by dt. What is phi? Phi is BA cos theta. So the cos component of area or the cos component of magnetic field should be taken. Here what we will do is that look, we are having the area. What is the area here? It is 10 centimeters, so I will take it as 0.1 meter. Totally we are having the area as 0.01 meter. Okay. Now I am taking the component of this, that is x component, that is 0.2 cos 45 degree, and sine component 0.2 sine 45 degree. Okay, you know that phi is equal to BA cos theta, that is B cos theta, that is 0.2 into cos 45 into area, that is 0.01. So what is the phi here? Phi here, that is 0.002 into 1 by root 2. Right, 0.002 into 1 by root 2, or we can write it somewhat simply as 2 into 1 by root 2 into 10 raised to minus 3. Okay, we got the phi. Finally, it is, the magnetic field is decreased to 0. So final, this is initial flux, initial. Now final flux is what? It is 0 because the magnetic field is 0. You know that epsilon, what? You know that EMF is equal to mu final minus of mu final, otherwise minus of mu final minus mu initial by what? Time taken. So here final is 0, so we will multiply this inside, so we get initial minus final by time. So what is initial? Initially it is BA cos theta, that we got as 2 into 1 by root 2 into 10 raised to minus 3. The other one is 0. By time is 1 second. So from here we get it as root 2 into 10 raised to minus 3 volt. They have asked you what is root x into 10 raised to minus 3 is given. What is this x? It is 2. This is the answer for this question. Okay. Yes. Simple question but humble question. Now next question. Yes, this is the next question. 1 second. Yes. So this will be the next question. A cylinder is rolling down an inclined plane of inclination. So they are telling that there is an inclined plane like this. Oh, why this inclined plane looks so odd? Okay. It is having inclination 60 degree, mass is rolling. First of all, you know that for any random body, here it is a rolling body. If it was a random mass like this, we take the acceleration as ma is equal to mg sin theta. Therefore a is equal to g sin theta. Right? Yes. So first of all, write that g sin theta. For a rolling body, the acceleration is equal to g sin theta by 1 plus moment of inertia along the center of mass by mr square. This formula please by heart. Direct questions can be asked. Acceleration is equal to g sin theta by 1 plus I com by mr square. Now substitute the same, that is g sin theta, g 10 into what is sin theta? It is root 3 by, what did they ask in the question? We should find something inside. Okay, root 3 by 2, it's there. Root 3 by 2 by 1 plus I com of what is this thing? Cylinder. What is the I com of a cylinder? It is mr square by 2, right? Mr square by 2. What cylinder is it? A cylinder is solid. Okay, look how it is mr square by 2. Cylinder is something like this. How ICM is that? Cylinder is something like this. You know that for disc, if you are having a disc and a thing is passed through it, a disc, it is mr square by 2. Really we elongated this disc to form. I told you that when we elongate something, the moment of inertia don't change. So we have here mr square by 2 by mr square. So we have this cancelling off. So A is equal to 10 into root 3 by 2 by 3 by one second. Sorry. Yes. 10 into root 3 by 2 by, we are having 1 plus 1 by 2, that is 3 by 2. 2 cancel. 3 root 3 cancel, we get root 3 here, that is equal to A is equal to 10 by root 3. So therefore x, y, what is this? X equal to how much? 10. That's the answer. X equal to 10. Now next question. Yes, so children, this is the next question. This question is very simple question really. Okay, first of all, this is a short dipole because it's 20 centimeter only, short dipole. So we can take what distance from center has to be the distance from the dipole to the given point. You know something that what magnetic potential of a dipole is equal to mu 0 by 4 pi into magnetic moment cos theta by r square, distance. Directly substitute magnetic potential 1.5 into 10 raised to minus 5. Mu 0 by 4 pi is 10 raised to minus 7 into magnetic potential cos theta. It's along the what axis. It is what situated on the axis. So cos theta is 0. So cos theta is 1 by r square. That is how much? R is 20. So 400 into 10 raised to minus 4. So this will be cut 10 raised to minus 2. Okay. Take this 4 the other side. We get 6 into 10 raised to minus 5 equal to 10 raised to minus 7 and by 10 raised to minus 2, that is 10 raised to minus 5. Cut into m. Therefore we get the magnetic moment as 6. Simple question. Okay, next one. Yes, so this is the next question. So it's from wave optics. In a double slit experiment shown. Okay, so what's happening here? I am zooming it. So there is a source here. The slits are respectively here and here. First of all, you know that delta x is equal to what? Delta x equal to what? Path difference equal to n lambda for a bright fringe, and delta x equal to n minus 1 by 2 lambda for a what? Dark fringe. So here they are telling the minimum distance between slit 1 and slit 2. So here minimum distance should be there. So the dark fringe is observed at P. So first of all, what should we do? We should give n equal to 1. First dark fringe, and we will solve the criteria. 1 second. That is here delta x should be equal to 1 minus 1 by 2 into lambda. That is delta x should be equal to how much? 1 minus 1 by 2 or lambda by 2. This should be the condition. So how to find this path difference? Here we can't use d sin theta and all. It's not proper because the source is here, not here. The source was here and the distance was equal, we should have used. But here the source is like this. So first of all, to find path difference, you know that what is the path difference? Yeah. What is path difference? And you know something that what is path difference? What is path difference? Yes, it is this distance. No, 1 second. Sorry. This is the distance between this point and the source. Now what is the distance through slit 2? Okay. Now through slit 1, what is the distance between this source and this point? That is this side, that is called x plus x, that is 2x. What is this x? According to Pythagoras theorem, you can write x square is equal to d square plus small d square. Therefore x equal to root d square plus d square. This is the value of x. Okay. Yes. So therefore, what can we write? This is here. Now the other path difference. So 2x is the 2x is the total distance between source and the point P. So that is 2d square plus d square. Now this is according to source 1. Now according to slit 1. According to slit 1. According to slit 2, it is x equal to just 2 times d. So now path difference is what? 2x minus 2d. That is equal to lambda by 2. Let us take this 2 common and bring it the other side. That is x minus d equal to lambda by 4. What is x? that is d square plus d square minus d is equal to lambda by 4. We should find the d. We should find what? D. Okay. Now before that, this is the question. We should find this. Rearrange this first. Rearrange this equation. Plus d. Now substitute the value of d. Capital D's value is given in the question to be how much? 0.2 meter, and the wavelength is given to be 400 nanometer. Okay. Capital D, I'll write it somewhere here. Capital D equal to 0.4 meter, no, 0.2 meter, and lambda is 400 nanometer. Substitute it here. D square, that is 0.2, right? So 0.4, 0.2 into 0.04 plus d square is equal to lambda, that is 400 into 10 raised to minus how much? 98 what? Nanometer. 10 raised to minus 9 into 4 plus d is how much? 0.2. Cut 200, so that becomes 2 into 10 raised to minus 9 into 10 raised to minus how much? 9 minus 2, 7. This thing is equal to 0.04 plus d square. Okay. Now continue it. 2 into 0.2, that is equal to how much? 4. That is 0.4 into 10 raised to minus 7. Let us write it as 4 into 10 raised to minus 8. And this is equal to 0.04 plus d square. Now take square on both sides. We get, now take root, square both sides. So we get 0.04 plus d square equal to how much? One second. Yeah. 16 into 10 raised to minus 8, 9, how much? Sorry, I took a small break. Okay, where did we come? Yeah. 10 raised to minus 16, I think. Okay. Now take this point for that side, that is 16 into 10 raised to minus 16 minus 4 into 10 raised to minus 2. So I think d square equal to, I will take 4 outside. 4 and 10 raised to minus 2 outside. So I get 4 into 10 raised to minus 14 minus 1. Okay. This is a very small value, right? I don't know if we can ignore it. No, don't ignore. Now take root of d. Now take root of d. That is, this thing is 4, that is 2 into 10 raised to minus 1. This thing is like 0.0000004 minus 1. It was, take it 1 itself, 1. Okay. 1 second. Okay. Please do it the other way. This way it will be very difficult to get the answer this way. This way means we should have squared it here itself. This way the problem is that calculation is more difficult. The other way it is somewhat simple. Okay, that's a thing happened. 1 second. Okay, you please expand it now itself. Expand it. When we expand, what do we get? We get d square equal to lambda by 4 plus d, that is lambda square by 16 plus d square plus 2 times lambda by 4 into d. So here what happened? 1 plus d square is also there. This d square cancel. Okay, cancels. So we get d square equal to lambda square by 16 plus lambda by 2d. Okay. So d square is equal to lambda square, that is 0.2. No, lambda square is 4 into 10 raised to minus 14 by 4 and plus lambda by 2d. What is lambda by 2d? Lambda is equal to 400 into 10 raised to minus 9 into 0.2 by 2. Okay. Yes, also 0.1 40 into this thing will go. Okay. So therefore d square equal to 4 cancels, 10 raised to minus 14 plus 40 into 10 raised to minus 9, or 4 1 2 3 Okay, if you calculate this, you calculate it, we get it. D square is approximately equal to 400 into 10 raised to minus 10. So if we take D, it will be how much? 200 into 10 raised to minus 5. Not 200, 20 into 10 raised to minus 5. So therefore D is equal to 0.2 millimeter. This is the answer. So you should give it as 0 is the answer for this question. Right? 0 is the answer. Okay. Yes. So next question we will be doing after some time. Okay, this is the next question. A 16 ohm wire is bent to form a square loop. So we are having a square loop. It is 4 ohm per side. 4 ohm, 4 ohm, 4 ohm. Okay. Is bent to form a what? Yeah. Is bent to form a square loop. A 9-volt battery with internal resistance 1 is connected across one of its side. Okay, one of its side, 4 ohm is here, one of its side, internal resistance 1 ohm and EMF 9 volt is connected. If a 4 μ of capacitor is across one of its side, so here we have a 4 μ of capacitor across one of its diagonal. One second. That is, this is the diagonal, not one second, I'll draw it properly. Here are 4 μ of capacitors connected. The energy is stored in the capacitors. That's the question. First of all, understand one thing. If I connect a capacitor like this, first of all, current will flow from this battery towards here. At this junction, the current have two ways to flow, here and here, but it prefer the capacitor way, so it comes like this. So right angle triangle, the current is usually flowing here. Okay. Sorry, one second. Okay. We are here 4 ohm. Now we connect a battery like this term. Connect it like this. Okay, no problem, right? Yes. So first of all, we should find what is the I effective. Okay. So that can be found out by what? Yeah, that is V by R equivalent. Equivalent resistance. Okay, let us find it. That is V is 9. 1, that is the internal resistance, plus here it is in series. These three are the current will flow like this. Here it will be flowing like this. Okay, so here it is in series. So 12 ohm. Here it is 4 ohm. So we should write it as 12 into 4 by 12 plus 4. 12 plus 4 is 16. Okay, 4 3. So we get 9 by 4 volt. 9 by 4 volt. Okay. Yes. Sorry, here in this question I had some confusion, so I had to do it in another paper and find it out. So I got it. So here we got 9 by 4 ampere. Now look, let us first think that no current is passing through capacitor. Here we are having I2, here we are having I1, and here is the total current I. You know that you know that I1 into 4, that is voltage. You know that in parallel circuit voltage is what? Equally divided. That should be equal to I2 into how much? 1, 2, 3, 4, 5, 6, 7, 8, 11, 12. Therefore I1 is equal to 4 times I2. No, 3 times I2. Therefore 3I2 plus I2 equal to 9 by 4. That is 4I2 is equal to 9 by 4. Therefore I2 is equal to how much? 9 by 16 ohm ampere. So through this 9 by 16 ampere flows. Perfect. Now this is the point A, this is the point V. First of all, we should find the voltage difference between these 2 points. That we can use the formula U equal to half C V square. So to find potential difference between A and B, we can use the Kirchhoff's rule. Right, we can use the Kirchhoff's rule. What is Kirchhoff's rule telling? VA minus VB equal to, use the voltage law. VA minus VB, that is equal to the current, that is I2 into the effective resistance. How much is it? 1, 2, 3, 4, 5, 6, 7, 8. 8. Therefore VA minus VB is equal to I2, that is 9 by 16 into 8. That's equal to 9 by 2 volt. This is the voltage difference, 9 by 2 volt. So we got 9 by 2 as V. You know that U equal to half CV square. What is asked here? It is energy stored by a capacitor. Okay. That is half into 4 into, in microjoule itself we need. So let us take 4 only into V square. What is V square? V is 9 by 2 to 9 by 2, that is 81 by 4. Therefore we are getting 81 by 2 into 10 raised to minus 6 what? Joule as the answer. Therefore x equal to what? 81. X equal to what? 81. That's the answer. Okay. Yes. This is a simple question only, but we need to use a little of high concepts of current electricity. It's a time consuming question, not time consuming. Thinking will take time. I took time for this question. First I didn't get the answer, then I did it here in other paper only I got it. Now the next question. Question is, I'll just tell the question. No need. I will take the questions itself. This is the next question. When the displacement of an simple harmonic oscillator is 1 by 3rd. So that in displacement is equal to 1 by 3 times of amplitude, and amplitude is equal to A. This is about amplitude. Okay. What is the amplitude? What is the ratio of total energy to kinetic energy? You know that total energy in a simple harmonic motion is what? Half K A square. And what is simple energy to and kinetic energy is equal to what? It is half K A square minus S square. Okay, these are the two formulas. Now just divide it. That is half K total energy to kinetic energy, right? So total energy is what? TE by KE, half K A square minus X square, no, not A square minus, half K A square by half K A square minus X square. K is same for the medium, half will be cutting off. So we are having A square. What is A? We'll write it as A square itself. A square by A square minus X square is how much? A by 3. So A square by 9. So we are having A square by A square, A square by 9 A square minus A square, 8 A square by 9. Therefore we are having A square is cut. We are having 9 by 8. This is equal to X by 8 is told here. So therefore X equal to 9. Okay. It was a simple question. This question is not going to be done in the exam hall. Yes. This is the next question. It's a question from electrostatic chapter. An electron is moving under the influence of electric field of an uniformly charged infinite plate sheet S having a, okay, you know that electric field due to an infinite charge placed, a thin plate is what? Epsilon 0 by what? Sigma by 2 epsilon 0. First thing we need is this. So you know that F equal to ma, right? F can be also written as Q into E, that's equal to ma. So therefore acceleration of the particle is what? QE by m. Here it is given as electron. The particle is electron. Therefore Q can be written as minus E. E is given as epsilon 0 by sigma by 2 epsilon 0 into m. So this is the acceleration of the particle. Here we got acceleration. Here we already the velocity of the particle. Look, the electron at t equal to 0 is at a distance. Distance at t equal to 0 is given. Speed at that time is given as 1 meter per second. 1 meter per second. Okay. The maximum value of sigma. If the electron strike S at t equal to 1 second. Okay. So first it's at a distance of 1 meter. That is, here is the plate, and the electric field is like this, and it is at here. Now if this is an electron, it moves against the electric field. So displacement is 1 meter, and that displacement is negative 1 meter. It is negative 1 meter. So we got all many values. So apply this in S equal to ut plus half at square. That is S equal to what? Minus 1 is equal to ut. U equal to 1 into t plus t is what? At 1 second, right? So 1 plus half into a is given here, that is minus E sigma by 2 epsilon 0 m. So sigma is what we want to find into t square, that is 1 itself. Okay. So we get what we will do, we'll take this here. So we get we'll interchange it. We get, therefore what we get, E by sigma into 4 epsilon 0 m is equal to 2. Okay. Now take it the other side. That we got E sigma by epsilon 0 m equal to 8. Therefore sigma can be written as 8 epsilon 0 m by E. By E, not E, 1 second. Epsilon 0 m by small e. This is what we get. This is what we are getting as sigma. They asked the value of alpha epsilon 0 m by E. This is equal to sigma. Here alpha, here 8. Therefore alpha equal to 8. We got the answer. This was we should think that this question is mixed with which two chapters? Electrostatics and rectilinear motion. Okay. Yes. Now the next experiment. Now the next question. Yeah, this is the next question. In a test experiment on a model aeroplane in wind tunnel, the following speeds on the upper and lower surface of the wing, 70 meter per second, 65 meter per second, is noted. If the wing area is 2 meter, the lift of the wing is, formula is lift of the wing equal to half into rho into v2 square minus v1 square into the total area. Just substitute it, half into what is sigma, 1 point, not sigma, rho, it is v2 square. That is v2 square is we'll take them not v2 square, sorry, I made a mistake, v1 square minus v2 square, or v upper square minus v lower square. Okay, that is 70 square minus 65 square into area is 2. So this 2 cancel. We get it as 1.2 into 70 into 70, how much? 4900 minus 65 into 65, 25, 32, 36, 39. So 5, 2, 9, 10, 11, 12, 3, 4, 2, 2, 5. Okay. So let us do 1.2 into 4900 minus 42255, 9 minus 2 7. Here we get 8 by 8 minus 2 6 0. That is 675 into 1.2. Just multiply 675 into 12. 12 5s are 60. 12 7s are 72. 72 6 7 8 78. Now 12 6s are, no, one second, some problem is there. No, one second. 675 into 12. 12 into 5 is 60. 12 into 7 is 84. 6. So that gives us what? It is what they have given 90. Okay, 9 here, not 90. 9. Now 12 into 6, what is it? It is 72 plus 9, 81. So it is 810.0 Newton. This is the answer. So by this, all the 10 questions from this shift comes to an end. But I think I will add some questions from the next shift 2 in the same video. Next shift 2. That is multiple choice question. Okay. Yes. This is the next question from the next. That is, this is from which shift? One second. Let me check the shift number. Yeah, this is from January 29th, second shift. January 29th, second shift. That's evening shift. Okay. Two sources of light emit with the power of 200. You know that power equal to number of photons into E. That is power equal to NHC by lambda. This is the formula, NHC by lambda. Okay, this is the formula. Okay, we got the formula. Now what should we know? Two sources emit the same power, the ratio of the number of photons. This is the number of photons. So first one, power 1 is equal to N1 HC by lambda 1. For next source, it is power 2 by N2 by N2 into HC by lambda 2. Simply cut HC. So we get power 1 and power 2 are equal, right? P1 is equal to P2 is equal to 200 volt. We can cut them also. So we get N1 by N2 is equal to what? Take this lambda 2 here. So this lambda 2 will go here, right? So take it the other side. Lambda 1 by lambda 2. Lambda 1 by lambda 2. Lambda 1 is 300 by 500. No need of nanometer. It will cut off. Okay. Therefore, N1 by N2 is equal to 3:5. 3:5. Let me check if this is the answer. Yes, this is the answer. Option number 4. Okay, this is a simple question. Next question. Yes, this is the next question. Yeah, this is a question on truth table. Look, when I am checking the trend, I can see that in morning shift, all the questions from Zener diode part of the semiconductor was asked, and one question for sure from semiconductor was there in every exam. So one question. So semiconductor is important. Learn just for one question. Just learn about the Zener diode. I will tell the important portion. Zener diode, rectifier, and truth table, and what? Forward and backward bias, or diodes. These many things you learn, you get. And this thing, Ni into number of electron into number of hole is equal to Ni square. This formula also is important. These many things you learn. And Zener diode is important, and truth table is the most important. Okay. Okay. So this is here. Now we are having A. So this is very easy to solve. Look, A we are having. So if we are giving, first of all we will take, whenever you get like this question, first of all you give 1 1. That is A equal to 1, B equal to 1, and check. So if you are giving A1, now this is here. This is an AND operator. Okay. You know that AND operator. This is OR operator. Okay. This is OR operator. This means like this, OR operator. Now this is NOT operator, NOT, or complement. So 1 is here, 1 is going here. Now this is going down. So NOT 1. So it is 0. It's becoming 0. Now the 0 is going here. Here we have 0. Now B also we are taking it 1. B 1 here, and B is going here. Here also 1. So 1 and 1 we get what? 1 into 1, that is equal to 1 itself, 1. Here 0 into 1, 0. And 1. And means what? Multiplication. Now it is going back. Now it is what? Going back to which operator is it? Which operator is it? Yes. We are having here we are having what? OR operator, or addition. So 1 plus 0 is, sorry, what happened? So 1 plus 0 is how much? 1 plus 0. Here 1, here 0. 1 plus 0 is equal to 1. So let us check the options and eliminate accordingly. 1 1 1, this can be the answer. 1 1 0, this is wrong. Here 1 1 1 should come. This can be the answer, or this is wrong. Now let us put, let us put here 0 0 0, here also 0 0 0. No need to put that. 0 1 1. So we'll put 0 and 1 accordingly. Now let us put 0 and 1 accordingly. Okay, 0 and 1 accordingly. That is 0 for A and B equal to 1. So here A is equal to 0 0, not to 0 1, not to 0 1. And B is equal to 1, here also 1, here also 1. 1 into 0, how much? 1 cross 0. 1 into 0, that is 0. 1 into 1, that is 1. So 1, 0 and 1. 0 plus 1, that's also 1. So we are getting 1. So the answer is 0 1 0. This is wrong. Here 0 1 1. So option 2 is the correct answer. Look, I usually use this method to solve it. Some people use another method, that also I will tell you. That is, they will make a characteristic. That is, a characteristic is that here we are having A, here we are having A complement, here we are having B, here also we are having B. Right? This is A into B, that is AB. Here we are having A complement into B. Now we are taking this AB and A complement into B. And here we are having OR operator or plus operator. So we add it. AB plus A cross B. This is the answer. Now you give the thing 1 into 0, 1. Let us give 1 and 1. For A and B I am giving 1 and 1. That is 1 into 1. 1 into 1 plus 0 into 1. That's equal to 1. Now let us give 0 and 1. 0 for A and 1 for B. 0 into 1, 0. Plus 0. 1 into 1, 1. That's we are getting it as 1. So if we give like this also, if we find a expression out of this, if we give a value also, you get. Here I prefer the other method. For me it is easy. That's the thing. So we got the answer as option 2. Now the next question. Yes, this is the next question. This is a question from errors. Okay. A physical quantity Q is found and the Q is written like this. So something is there. Q is not don't take it as what is this called? What charge and all. Q is a random quantity and the Q can be found out as A raised to 4 B cube by C square. Now percentage error in A by A into 100. That is the percentage error in A, that is 3. Now percentage error in B, that is equal to 4. Percentage error in C, that's equal to 5. These three percent. Then the percentage error in Q. You know that Q is equal to A cube, A raised to 4 B cube plus C square. You have learned that if there is a quantity A and we are having B square, this thing, if you are having a quantity, if this is a quantity, A is equal to B square, then the percentage error in A is equal to what? 2 times the percentage error in B multiplied here. That's the thing for raised to power. If we are having A, if it was A is equal to B by C, or if it was equal to A equal to B into C, anyway multiplication or division, the percentage error in A is equal to what? Yeah, percentage error in B plus. For multiplication and division it is plus, not minus. For division both it's plus. Percentage error of B plus percentage error of C. So here what is happening? Therefore percentage error of Q here is equal to 4 times percentage error of A plus 3 times percentage error of B plus 2 times percentage error of C. Okay, now multiply. 4 into percentage error of A is how much? It is A is 3 4 5. Yeah, 4 into 3 plus 3 into 4 plus 2 into 5. Right? 2 into 5. Now multiply, you get the percentage error in Q. That is 12 plus 12 plus 10. That is 12, 12, 10, 1, 2, 3, 4, 3. 34 percentage. 34 percentage is the error. 34 percentage. This is the answer. This is the answer. So simple question. Okay. Now next question. Yes. So this is the next question. A question from alternating current chapter. Here voltage of the alternating current is given as V equal to 100 sin omega t or 100 t volt, and current is given as 100 into 10 raised to, it's milliampere, it is given here, milliampere, so we will convert it into ampere. That is 100 into 10 raised to minus 3 sin 100 t plus pi by 3 ampere is the current. Power is, what is power? Vrms into Irms into cos phi, or power factor. Power factor. What is phi? What is phi? It is phase difference. Phase difference. Right? Phase difference. You know that cos phi equal to R by R. R by impedance. R by impedance. This formula is used when impedance, when the different things, that is inductance, capacitance and all is given. Here nothing is given, but here we have two equations. From that two equations you can find the phase difference. What is phase difference? Here the phase difference is pi by 3. Phase difference, that is plus pi by 3. Therefore the phase difference here is what? Pi by 3. So from that, P equal to, we get Vrms into Irms into cos, how much is it? Pi by 3. That is 1 by 2. You know that what is Vrms? What is the maximum value? 100. You know that Vrms is usually 100 by root 2. For I it is 100 into 10 raised to minus 3. 100 into 10 raised to minus 3 by root 2 into cos pi by 2, that is 1 by 2. So here it will become 100 into 10 raised to minus 3, that is 10 raised to minus 1. 10 by 4. 10 by, that is 4. This is equal to 2.5 watt. 2.5 watt. This was a simple question from alternating current chapter. 2.5 watt. That is option C. Yes. Next question. Yes. This is the next question. That is, temperature of a gas is given as 2 into 10 raised to 25 molecules per cubic meter at 1.38. So we have to find the temperature. So first of all, let us write the ideal gas equation. PV equal to N, that is number of molecules into kBT. So P equal to N by V into kBT. Here look, this 1.2 into 10 raised to 25 molecules per cubic meter. What is this? 2.2 into 10 raised to 25 molecules per cubic meter. It is what? Number of molecules per volume, right? So N by V can be substituted as what? 2 into 10 raised to 25. Kb is given as what? 1.38 into 10 raised to minus 23. Temperature is what we have to find. Look, here pressure is given in 1.38 atm. But we have to get this in Kelvin. So we have to convert pressure into Pascal. That is, just multiply by 10 raised to 5 or 101.2 kilopascal accordingly. But 10 raised to 5 is giving us more accurate answer. So I am doing that. So 1.38 into 10 raised to 5 by 2 into 10 raised to 25 into 1.38 into, 1 second. Okay. 1.38 into 10 raised to minus 23 is equal to T. 1.38, 10 raised to 20, 10 raised to 5. Now we get 0.5 into 10 raised to 3 is equal to T. Therefore temperature is equal to 500 Kelvin. Option what? 1. Yes, that's the answer. Okay, that's the answer. Simple question. Now next question. Yes, this is the next question. This question is from circular motion. circular motion, what do we have here? A stone of mass is given and is moved in a vertical circular motion of radius 1 meter, making 10 revolution per minute. The tension in the string is, first of all, what's happening here? We are having a vertical circular motion. So the tension in the string at the lowest position. Here we are having mg, we are having tension, and we are having another force known as the centripetal force, that is mr omega square. What is centripetal force? Centripetal force is equal to mv square by r, that we know, but in terms of omega it is mr omega square. mr omega square. So from here we can understand that tension minus mg is equal to mr omega square. Therefore tension can be easily added as m into r omega square plus g, right? This is the formula from here. But the thing is that here omega is given, here that it is given, omega is not given, instead it is given 10 revolutions per minute. First of all, how much is one revolution? Look, first of all you have to convert it into radian, right? Omega is equal to, what's its unit? It's radian per second. 10 revolution per minute is given to us. How to convert it? One revolution is equal to 2 pi radian. So multiply with 2 pi radian per 1 minute is equal to 60 seconds radian per second. Now we get it as omega is equal to what? Pi by 3 radian per second. We get this. Okay. Now substitute it here. T equal to m, that is 0.9 into r into omega square. It is given, something is given here, law. Omega pi square is equal to 9.8. So r omega square means pi square by r is 1, so it is pi square by 9 plus what? Plus 9.8. It is given that pi square is equal to 9.8, so we can take 9.8 outside and we get 1 by 9 plus 1, that is 9. That is 0.9 into 9.8 into 10 by 9. Here we get 10, 10, 10 cancelled. So we get T equal to what? Tension equal to 9.8 Newton. That is option number what? 2 or 3? Option number 2. Yes, we got the answer. This was also okay question. The next question. Yeah, this is the next question. Look, I am taking 5 minutes time in between because I have to do this question. I am doing it in another paper. I am doing it here itself, like in this page itself, and I am erasing it and explaining it. Okay. Some questions I don't do, but some questions, if I think if there is some confusion, I do usually. So let us go to this question. The bob of a pendulum was released from horizontal position. The length of the pendulum is 10 meter. If it dissipates 10% of its initial energy against air resistance, the speed. Look, first of all, what happened here is that, look, we have a pendulum here at the initial position. Now this thing is pulled. It's like this pulled, and now it is here. So the height is equal to the length of the pendulum, that is 10 meter. You know that what? Energy is equal to what? mgh. That's equal to mass into 10 into h is how much? 10 itself. That is equal to 100 m. Now they are telling that there is a change in energy happening, that is 10% of energy is lost, that is 100 m by 100 m minus 100 m, that is new energy is equal to 100 m minus 100 m into 10 by 100. Okay. Therefore the new energy is equal to 90 m. This is the new energy, at the new energy. Now with this new energy, it is coming to its mean position, that is down. You know that at the mean position the U is equal to 0 and kinetic energy is equal to maximum. So therefore from here we get what? Kinetic energy is equal, total energy is equal to kinetic energy is equal to energy. You know that you should not use 100 m, you should use 90 m. That's a new energy, 90 m. M get cancelled. So V square is equal to 90 into 2. So V is equal to root 180. Now look at the options. Root 180 you can write it in different ways. But in options, first of all we will try to write it as 36 into 5 is equal to 180. So we will take 6 outside. So 6 root 5 meter per second is the answer. Option 1 is the answer. Okay, this question was also easy. Okay, yes. Now next question. Yes, next question is one of my favorite questions. Okay, we got this as the answer. Now next question. Yes, this is the next question. It's a question from optics. Okay, optics is a chapter that I love. That's the only reason why, look, I don't usually take physics chapters, but optics is one chapter that I took in the online class because one of my favorite chapter. Okay, if the distance between object and its 2 times magnified virtual image by a curved mirror is 15 centimeter, the focal length of the mirror. So magnified, 2 times magnified. You know that magnification, it's a mirror. So magnification is equal to minus V by U. Here it is given as 2 times magnified. 2 times magnified. If it is virtual, we get it positive. Why we get it positive? Because minus is here. We get V as positive and U as negative. The negative cancel, we get it as positive. So we can write 2 is equal to minus V by U, or 2 is equal to V by U. And from here we get V is equal to 2 times U. Now we have focal length with us, that is 15 centimeter. Sorry. Now we have the distance between the virtual image. One second. If the distance between the object and its 2 times. Now we got V equal to 2U. You know that 2U plus. Sorry, one second. Yes. You know that V equal to 2U. We got this. Now they have told that 15 centimeter, like if you are having a mirror here, you are having an object image, magnified image. This is V, this is U. They have given that U plus V is equal to 15 centimeter. Okay, perfect. U plus V is equal to what? 15 centimeters. Now what happens? U plus V equal to 15 centimeter. So we'll add it. That is 2U plus U is equal to 15. That is 3U is equal to 15. Therefore U is equal to how many centimeter? How much centimeter it is? Minus U is equal to how much centimeter? 5 centimeter. Okay. Now you know that V equal to 2 times U. So multiply, you get 2 into 5, that is 10 centimeter. Now we have to find the focal length. You know that 1 by F equal to 1 by V plus 1 by U. Here U should be negative, V should be positive. So 10 plus 1 by minus 5. So that's equal to minus 5 plus 10 by. So don't write like this, it's confusing, right? So that's equal to 5 minus 10 by 50. That's equal to minus 5 by 50. 1 by F. Therefore F is equal to minus 10 centimeter. That is option 3. That's the answer. Okay. Now let us go to, we will be doing 2 more questions. Okay, now the next question is, yes, this is the next question. 2 particle X and Y. Here this is from magnetic sources of current, or the chapter's name was electricity and magnetism. I don't know. Moving charges and magnetism. Two particles X and Y having equal charges are being accelerated through same potential difference. One second. Okay. Same potential difference. Okay. Thereafter, they enter normally in a region of uniform magnetic field and describe circular path of radii R1 and R2. The mass ratio of X and Y. Okay. You know one thing, that R equal to mv by qb. This is a formula, right? So first of all, we will take R1. If it was R1, it will have become R equal to mv by qb. Okay. mv can be written as root 2m ke by qb. You know that ke is equal to ev naught. Substitute it. You can write it root 2m ev naught by qb. So this is the formula that we required here. Now divide. R1 by R2 is equal to same charge. They are having same charge. One second. Yeah, they are having equal charge. So inside the same magnetic field. Therefore qb will be cancelled. Okay, so we will be only having root 2 m1 ev naught by root 2 m2 ev naught. This will be the ratio. E cancel, V naught, they accelerate to the same potential. V naught cancel, 2 cancel. So we get R1 by R2 is equal to what? Root m1 by root m2. They ask the ratio of mass, that is m1 by m2. So square both the sides, we get root R1 by R2. Sorry, 1 second. Square both the sides, you get R1 by R2 what? Whole square. This is option 2. Option B or option 2 is the answer. This is the answer. Yes, we got it. It's a simple question. Next question is question number 40. Yes, so this will be the last question of this session, that is, in Young's double slit experiment, light from two identical sources superimposing on a screen. The path difference between the two lights reaching at a point on the screen is 7 lambda by 4. That is path difference. Delta x is equal to 7 lambda by 4. The ratio of intensity of the fringe at this point with respect to maximum intensity. First of all, they have given us the they have only given us the path difference, that is 7 lambda by 4. You know that intensity is equal to I1 plus I2 plus 2 root I1 I2 cos phi, or the path or the phase difference. Here intensity from identical sources, therefore I1 and I2 are equal. So we can write it as 2 I naught plus 2 I naught into I naught, so it will be I naught cos phi. So if we can find the phase difference, we will get the ratio. So you know one formula, that phase difference is equal to what? 2 pi by lambda into path difference. Path difference is a formula. So apply it in the formula, that is 2 pi by lambda into 7 lambda by 4. Lambda 2 1, that is 7 lambda by 2 is the path difference. Now intensity equal to 2 I naught plus 2 I naught cos delta phi. Substitute 2 I naught plus 2 I naught cos 7 pi by 2. 7 pi by 2 means how much it is? 1 second, let me check. 7 pi by 2 means 2 pi plus pi by 2. 3 pi plus pi by 2, that is 2 into 3, how much? 6 plus pi by 2. That is, it is like this. That is pi, 2 pi, 3 pi plus pi by 2 here. So it is here. Okay. So cos pi by 2 will be how much? 0. It is 0. So I is equal to cos 7 pi by 2 is what? Equal to 0. So it will be 2I naught. 2I naught. Now what is the maximum intensity? Maximum intensity equal to 2I naught plus 2I naught cos phi. What is the maximum value of cos theta? It is 1. So 2I naught plus 2I naught. That is equal to 4I naught. This is the maximum intensity. Now the ratio of what? Maximum intensity intensity of the fringe at this point to maximum intensity, that is I by I max is the question. I is equal to 2I naught, I max equal to 4I naught, therefore that's equal to 1 by 2. Option A or option 1. This is the answer. So this is about this question. This question was also simple question. Look, MCQ questions are comparatively simple. Integer questions, 5 of them will be simple and 5 of them is difficult. But this year for integer question only 5 questions are there. So the chances like 3 questions will be simple and 2 questions may be a little difficult, not that much difficult as a difficult question in 2024, because some questions and all are lot to think on that question, but that much level may not be coming. But you can expect in one of the paper, in 10 papers, one of the paper the numerical will be all the 4 or 3 to 4 numerical will be toughest numerical of this paper. Okay, so this is about this. Now we will be doing the rest questions of this session, shift etc in the next thing, and we will be also doing the same thing for chemistry. Maths also, let me think, because maths is a subject that takes a lot of time for me to solve. So I have to make easy formulas and be able to follow. Otherwise the video's length will be 4 or 10 or 4 to 10 hours and all. Just explaining and solving, that's a problem. So thank you.